Here we see a thin section view of a garnet-sillimanite gneiss in plain polarized light. The opaque grains, showing in black, are ilmenite. Ilmenite is one of the most common of the opaque minerals in thin section. The blocky, high relief grains with many fractures are garnet. And the long needle-like grains are sillimanite. In some places we see end views of sillimanite needles, and they appear as small squares or rectangles. As we rotate the stage, we don't see any changes. The uncolored minerals remain uncolored and are not particularly exciting. But when we insert the upper polarizer, things come alive. The garnet, because it is isotropic, remains black with stage rotation. The sillimanite shows up to second order interference colors. They change as we rotate the stage. And the quartz and feldspar show their usual white, gray, and black interference colors. Here is a view of a biotite muscovite schist in plain polarized light. And here it is in cross polars. Notice that the muscovite gives quite high order interference colors, bright pastels, and the biotite has pastel interference colors, but the brown color of the grain makes them almost impossible to see. If we switch back to plain polarized light, we can also see that this sample contains kyanite. If we switch back and forth between XP and PP views, we see that kyanite's interference colors are never greater than first order. So, as we rotate the stage, most of the color variation comes from the muscovite, but the biotite brown colors vary somewhat. And the quartz and feldspar change from white to gray to black. Here's a view of a dolomite marble in plain polarized light. The vague stripes you can see are twinning. Most minerals only show twinning in cross-polarized light, but dolomite and calcite show it in plain polarized light. And now we insert the upper polarizer to get cross-polarized light. Dolomite has exceptionally high birefringence, so the interference colors are very, very high order, washed out pastels, almost appearing white. It's impossible to estimate the order of interference.